Welcome to lecture 5, Introduction to Object Oriented Programming, and in today's class we are going to see inheritance in the example of Java, and we are going to see polymorphism. So, in the last class we had seen the single inheritance in C++, and in this lecture you can see the code in Java, alright. So, the same code, you have a class vehicle, so which is called as a base class, alright. So, this is the base class and I have a data member called brand, right, whose data type is string. So, like C++ we have written the member function, here you call it as method, in Java you call this as method. Okay. So, we have a method called show brand, right. So, return type is void and you are printing, you have only one statement system.out.println. So, which will print. So, the brand will be printed in the double quote and then whatever the value or whatever the string of brand will be printed, alright. So, this is of base class in Java, and if you look there is no semicolon, whereas in the case of C++ we had semicolon. So, this is the base class, right, vehicle is your base class A, right. So, this we call it as, because we use the notation A. So, A is the base class, and we have a derived class called car, right. So, we have a derived class called car. So, the car is extending the vehicle. So, that means vehicle is a base class. I will just draw the diagram, vehicle is a base class. Okay. So, your car, the derived class will inherit, right, the properties of vehicle, right. So, this is the, you in fact call it as a super class, in Java you call it as a super class, right. This is same as base class, and a car is a subclass in Java. So, what we studied in C++, it is a derived class, right. So, here you use class car extends, right. So, we use extends vehicle, alright. So, like what we have done in the case of C++, you put class car and then public vehicle, something like that we have done. If you recall what we have done in the case of C++, syntax is slightly different, alright. So, here we use the keyword called extends. So, car extends vehicle, right, the class car extends vehicle, that means the car can use the data member and methods, right. Assume that if it is publicly available, that can be used, right. So, here you have a data member called model whose return type is, whose data type is string, okay. And then you have one more method, alright. So, you have a one more in the sense we have already discussed one method in superclass, alright. In the subclass you have another method called show model, right. So, it is a void method. So, you have system.out.println model. So, the model will be printed, that is also string, alright. So, now we will see in the main program, it will be interesting, alright. In the main program, so let us consider my car, right. So, main. So, you have a void main almost like in C++ syntax. So, you have my car which is an object, alright. So, this is the object you are instantiating in the class car. So, car is a subclass, if you go back, car is a subclass. So, under subclass I am creating an object. So, the new operator, here you have a new operator, alright. So, suppose I want to write declare an array, right, in C++, int a of 10, let us assume in C++, right. So, what I will do, I will use a dynamic array, alright. So, dynamic array you might have used a new operator. I am just recalling the procedural oriented programming, you might have done this, right, int star a equal to new int of 10. So, this is array and it is called a dynamic array of 10 elements, right. So, you might have used a new operator in a similar way when I am creating an object. So, in Java all are dynamic, alright. So, when you want to create a dynamic object, you use the new operator, right, and then this is we are going to study this is constructor, right. So, this is a constructor. So, dynamically the memory space will be allocated for my car, right. So, that is the meaning, and then you can see, right. So, my car dot brand, right. So, it can access, right, my car can access brand, brand is available in your superclass, right, superclass A, and I call this as B because we have used the notation, right. I call this as B, right. So, you can find brand in superclass or base class, right. So, here your object what you have created in B, right, that can access, right, the object that you have created in main. So, that can access both brand and model, right. So, this is available in superclass and this is available in, I mean to say brand is available in superclass A and the model is available in subclass B. So, now my car you have created under car yes B, alright. So, car is B, my car the object you have created under B. So, now this can access any because you are using the inheritance property, right. So, now when your object is invoking the method show brand, right. So, show brand is available in the base class, right. So, this is possible and this will print whatever be the brand, right, Toyota, and my car dot show model, right. So, which will print Corolla. So, that is what you are getting as the output, right. So, this program we can see in Eclipse also, alright. So, if I open Eclipse, right. So, here you go the same program, if I run here you can see you are getting the output, right, Toyota and Corolla, the same program whatever I have explained, the same program if you run you will get the output Toyota and Corolla. So, we have seen only single inheritance and rest all other 4, right, we will anyway study in detail in the coming weeks, right. So, rest 4 we will study slightly later. So, now next concept is polymorphism, right. So, we know poly, the meaning of poly is many, right, and in the sense forms. So, many forms. So, suppose I want to use a function, right, member function, I will go back to C++. So, in the member function suppose you are using, I in fact gave an example in the introductory class, suppose you are using max function. Can I use the same function name twice or multiple times? Yes, you can do that, right. So, which is called as polymorphism, right. So, I can use the single entity which is a member function in several forms, multiple forms. One I can use maximum of 2 numbers, another I use maximum of 3 numbers, or one I use maximum of 2 integers, another maximum of 2 doubles, right, or a maximum of 2 strings, or maximum of 2 character array, or maximum of 2 characters, right. So, you can use the same function name, right, multiple times. So, that is called polymorphism. So, here in the case of C++ and Java object oriented programming, just now we studied inheritance. Suppose you use let us say a same function name, right, in base class as well as derived class or super class as well as subclass, right. So, which one will be called? So, that we are going to see, right. So, in that case we are dividing this into compile time polymorphism and runtime polymorphism, right. So, what do you mean by compile time polymorphism, right. So, the compile time polymorphism in C++ or even in Java. So, this can be achieved when we talk about the concept called function overloading, right. So, what do you mean by overloading? So, suppose that is what I said, in one maximum function I use to find maximum of 2 numbers, another one I use to find maximum of 3 numbers. That means, in one case I am using 2 arguments and another case I am using 3 arguments, right. So, it is based on changing the number of arguments, that is the meaning. Or I said another example, in one case I use integers, maximum of 2 integers, another case I can find maximum of 2 characters. So, that means I am changing the type of arguments, right. Either number of arguments or type of arguments, you have to be very careful. You cannot use the same type of arguments and then you cannot say the return type is different, alright. So, the function will look, for example, you are writing float, you write return type and then you try to write let us say max 1 of let us say int a comma int b, right. So, this is one function. So, another function you are saying your int is a return type and you are using the same name int a comma int b. So, now if you look, the arguments are same, right. Now, if you look, the arguments are same, but the return type is different, you can claim it may work. So, unfortunately this will not work, this will throw an error because when you are calling max 1 in the main, right, max 1 of let us say you are passing 7 comma 8. So, which one will be called, right, the compiler will get confused, right, and then this program will throw an error. So, the arguments when you use, you have to be bit careful, right. So, the argument should be different and the number of arguments, suppose I use let us say int c, in the second program I use one more argument int c, that will work. Okay. So, overloading is nothing but changing the number of arguments or type of arguments, which is called the compile time polymorphism. So, anyway, from the program I will explain one more time what is compile time polymorphism. Suppose you take this particular example, right. So, here you see the name of the class is, you are calculating something cal, right, and here you have a function name called add, right, whose return type is integer, correct, and then here you have two arguments, both are data type integer, right, both are having data type integer. So, two arguments you are using, right, you are using two arguments. So, here you are returning a plus b. So, addition of two numbers, right, you are returning, and another function. So, let us say int add, so which is having a, b and c, right. So, here you have, so let us say 3 arguments, all are having integer data type, right. So, here you are returning a plus b plus c, right. So, now this is 3 arguments. So, this is 3 arguments. So, you have 2 functions, right, of same name. So, these are all member functions under the class calculation, right. So, cal, simply cal, right, the class cal. So, you have 2 member functions, one is this with 2 arguments, another one is this with 3 arguments. But the beauty over here is both are having same name, right. So, one is returning a plus b, that means sum of 2 numbers, another one is returning sum of 3 numbers. So, now when you go to the main program, right, so you have an object called c whose class is cal, right. So, you are instantiating an object under cal, name of the object is c. So, now this c will invoke one addition function, right, one of the functions, both are same name. So, 10 comma 20 you are passing 2 values. So, here you are passing 2 values, and the next one you are passing how many values? 3 values. So, now the question is which one will be called. So, for the first case line number 16 you have 2 values, right. So, the compiler will decide to call the 2 argument function because you have passed 2 values, right. So, a will take what is the value? A will take 10, b will take 20. So, in this case a will take 10 and b will take 20, and then there is a addition, return a plus b, right. So, the addition will happen, we know the output should be 30, right. So, the second case you are passing 3 arguments, right, 3 values, in fact you are passing 3 values 12, 20 and 23 pass by value, correct. So, that means since you have passed 3 values, the 3 argument member function will be called. So, A will take the value how much 12. So, here in this case A will take the value 12, B will take the value how much 20 and C will take the value 23, right. So, these 3 will be added, return A plus B plus C, right, 35 plus 20 55. So, the next answer I have to get 55, this is the output I have to get, right. So, if you look at the output you are getting this 30 and 55, right. So, now the question is how it is being chosen. So, when you are calling add 10 comma 20, when this object C is invoking add, right. So, 10 comma 20, the compiler will decide during compilation time, right. So, during compilation time compiler will decide, right, since you have passed 2 values, right. So, the 2 argument member function will be called, right. So, this will be decided during compile time, right. And similarly, in line number 17 you have passed 3 values, right. So, the compiler will decide to call 3 argument function, right, 3 argument member function, right. So, these 2 will be decided during the compile time, therefore, this is called compile time polymorphism, or this is another name called early binding. Or you can also call this concept as static binding, right, all are same name, static binding, early binding and compile time polymorphism, alright. So, the main idea, the beauty of the object oriented programming, you can use the same function name as many times as possible, only thing it has to follow this rule, alright. So, you have to keep in mind the number of arguments or the type of argument should be changed. So, you call this as compile time polymorphism. So, the next one is runtime polymorphism, right. So, it is decided during runtime, right. So, we have talked about inheritance extensively, we studied about the single inheritance, right. So, if you recall, so we know what is meant by single inheritance. So, there you have base class and derived class, I will talk in terms of C++, right. Assume that like a previous program you have the member function or method in base class as well as derived class, right, the same name, assume that dot add, right, assume that similar to or otherwise you assume that you are using some factorial or NCR, right. So, this function let us assume that it is available both in base class as well as derived class. Now, you have created an object. So, let us assume you have created an object under derived class, because that is what the example we had seen. So, now the question is, when this object calls, let us say NCR, this is a function, member function, right. So, this is a member function. So, when this is calling the function, right, when the object is invoking the function, the object that you have created under derived class. So, now the question is which one will be called, because now assume that both are public, alright, all the entities are public like data member and methods or member data or member functions are public in base class. So, now the question is, just now we have studied, right, in one of the examples. So, when you are creating an object in derived class, this can also access the data member or methods or member function or member data, right. So, can be accessed if it is in public, right. Suppose the names are same, right, which one will be called, right. Suppose the names are same, which one will be called. So, this will be decided during runtime. The previous case, the previous example, compile time polymorphism, I said that the dot add function, so which will be decided by the compiler during compile time. Whereas, here in this case slightly opposite. So, this will be decided during runtime, alright. So, this polymorphism concept, right, this can be achieved by using function overriding. So, we have seen overloading in the case of compile time polymorphism, and this is called function overriding the same function name. So, that may appear as many times, right, more than one time or more than two times, right, or several times. So, now the question is which one will be called, right. Sometimes it is a combination of your compile time and runtime possible, right, with the arguments are different, which one will be called, right. So, now the question is assume that base class same function is there and the derived class same function name is there. So, which one will be called? So, this will be decided during runtime and this can be achieved using function overriding, right. And I also said this will be the overridden functions is resolved during runtime, that is very important, right. So, you call this as runtime polymorphism. So, assume that you have a same function name in both superclass and subclass, right, or base class and derived class, right. And also here in this case the number of parameters, return type, right, can be same, right, whereas we have some constraint in compile time polymorphism, right. So, here not a problem, both the functions may be identical, inside you are doing something, right, extra. So, one you are writing I am in the base class, C out I am in the base class, and here the other one C out I am in the derived class. But when you are writing the function, right, the number of arguments, the return type all are identical, right. So, even if it is identical, right, so this can be achieved, right. So, which one has to be chosen can be decided by the compiler during runtime, right. So, therefore, this is called the runtime polymorphism, right. So, here you have seen, right, the concepts like function overriding, right. So, we have seen overloading and here you call it as function overriding and this can be achieved during runtime, right, and also the superclass and subclass are involving, right. So, because in superclass and subclass you can find the same function name. So, here it is also called dynamic binding, late binding is also called late binding, and you can also call this dynamic binding. These are the other names of runtime polymorphism, late binding and dynamic binding, whereas in the case of compile time polymorphism we have studied it is early binding and static binding, right. So, all the names are same. So, you can call runtime polymorphism or late binding or dynamic binding. So, we can see this example, simple example. So, let us assume we have class P, right. So, let us assume we have class P, right. So, under class P, right. So, this is going to be like a base class, right. So, this is going to be like a base class and here we have member data called P, right, whose data type is integer, right. So, we have a member data called P whose data type is integer, right, and then you have, so this is I will call it as a member data or data member, whatever way you write, fine, member data, and you have one member function called display, right. So, if you look there is no argument and return type is void and cout statement class P, right. So, this is a class P, you are putting a semicolon, right. So, you have class P and now class Q is publicly inheriting P, right. So, that means P is the base class and Q is inheriting the properties of P, right, the inheritance, and from the inheritance I am explaining what do you mean by runtime polymorphism. So, here, so this is also common statement derived, okay, derived class declaration, it is in fact a single line. So, it is a common statement, okay. So, now if you look you have another member data, right, in class Q Another meaning is in the base class you have one member data, right. So, this is the member data for class capital Q, right. So, Q is inheriting P and it is having same function name, member functions of both the classes are exactly identical. This is what I mean. Here no argument, there is also no argument. Here the return type is void, there is also return type void. But inside the function you can change, that is what exactly I told, right. So, here C out class Q, here C out class Q. So, now the question is, right, suppose Q, right, I have an object Q1, alright. So, this is a C++ code only, I put like this, okay, Q1, I am creating an object Q1. So, now Q1, right, which will call the function, alright. So, now assume that Q1 is calling the function, display function. Now, the question is which one will be chosen, right. So, Q1 is under Q, right, it is the subclass, alright. So, you have an object Q1, now assume that Q1 is invoking display, right. So, this we will extensively study, right. So, this is just an introductory class of polymorphism. So, now when your object Q1 is invoking display, so which function will be called, right, which member function will be called. So, this will be decided during runtime, right. So, this will be decided during runtime, you can think of, alright. Anyway, extensively we are going to study. So, I am giving like a reading assignment. So, you can write a program and think, so which one will be called. So, extensively anyway we are going to study so many, because we can create like this, let us say P1, alright, and then P1 dot display, because I have not introduced constructor and all. So, we can play with that. So, P1 dot display, right. So, now the question is when P1 is invoking the same function name display, which one will be called, right. So, what we can do, so once extensively we study about the polymorphism and when we run certain programs, so you can understand, alright. So, which one will be called, right. So, this is about the polymorphism. So, in the introductory lecture, so far we have studied the classes and objects. So, now you can able to write some sample programs or the basic programs on the classes and objects. So, what you can do, you can start writing the code, right. So, during the basic programming, right, the basic programming like procedural oriented programming, you might have written some code, right. You started with hello world, you started with addition of two numbers, right, or finding out the number whether it is prime or not. So, what you can do now, you have to create an object and classes, right. So, let us assume you are writing a program for finding out whether the given number is prime or not. Let us assume you are using completely the object oriented programming, whatever you have studied in the last 5 lectures, right. So, to create a class, right, make a class and create an object, and from there write member functions, create various objects, right. So, write a member data and member function and write the logic. So, as I said, when you are doing it in object oriented programming, you can elegantly do that, you can split the programs, right, you can split a program into several classes. So, this facility is available in object oriented, and when you look at the last main program, it may look like 3 or 4 lines, alright. So, that means you have made everything with the different classes, right. So, with the help of classes and objects, you can start write the basic programming, right. So, whatever you have studied in procedural oriented programming, you start writing with the help of classes and objects, and you now have a little knowledge on inheritance and polymorphism, alright. So, try to do that. You might have studied function overloading, right, in procedural oriented programming. So, here you have the concept of object oriented programming, right, and the very basic concepts like classes, objects, inheritance and polymorphism. So, you can try to write whatever the code that you have studied in the basic programming. So, try to write, and then extensively in the next class extensively we study the classes, objects, and then I will introduce, right, extensive classes and objects, because we have to introduce the block inside the class, constructor and destructor more importantly, right, the constructor and destructor, because when you are using C++, the memory management is very important, right. So, whenever you are not using certain objects, how I can flush it, right. So, this we will study, right, in the next few classes. So, classes and objects, and you will study constructors and destructors. So, with this I am concluding the fifth lecture. Thank you very much.